Mathematics 1 DM015 Mathematics Unit KMNS. Chapter 4 Functions. In this chapter, we have 4 subtopics and we will discuss 4.3 Composite Functions. At the end of this topic, students should be able to represent a composite function using an arrow diagram, find composite of two functions involving linear, quadratic, cubic, and set functions only. Composite function. What is composite function? Definition. Consider two functions f(x) and g(x). We define the composite of f and g as f composite gx equals f gx and equals f gx, meaning that the output values of the function g are used as the input values for the function f. From here, we can see gx is the input for function f. If we're representing f composite gx by using an arrow diagram, x is the domain for function g. Therefore, gx is the range for function g. If we have another function f, with gx is the domain of function f, the range is f gx, which this is f composite gx, f composite g. Similarly, if we representing g composite fx by using an arrow diagram, x is the domain of function f, and the range is fx. Now, if we have another function g with input fx, therefore, the output or the range of function g is gfx. Observe that x is the domain for function f, and fx is the range of function f. At the same time, fx is the domain of function g, and the range for function g is gfx. This is the composite function g composite f. Example 1. Given f with set of elements of ordered pairs -1, 2, 1, -4, 2, 1. G is the set of elements ordered pairs 0, 1, 1, 2, 3, -1. And H is set of ordered pairs -4, 1, 2, 0, 3, 3. Find the composite functions f composite g and g composite h. By representing g into an arrow diagram, g has domain 0, 1, 3. And the range is 1, 2, -1. 0 is mapped to 1, 1 is mapped to 2, 3 is mapped to -1 by function g. And if we have another function f with domain -1, 1, 2, which is the output for function g, 1, 2, -1. The range of function f is 2, -4, 1. 2, -4, 1. And this is the output for function f. Observe that this is f composite g with the domain are 0, 1, 3 from here. And the range of f composite g are -4, 1, 2. Given f equals -1, 2, 1, -4, and 2, 1. G is set of ordered pairs 0, 1, 1, 2, 3, -1, and H set of ordered pairs -4, 1, 2, 0, 3, 3. By using an arrow diagram, H has domain -4, 2, 3, and the range is 1, 0, 3. For function g, the domain are 0, 1, 3, and the range are 2, 1, -1. Therefore, G composite H equals ordered pairs -4, 2, 2, 1, 3, -1, which the domain are -4, 2, 3. And the range are 2, 1, -1. Given that fx equals 1 plus x and gx equals x squared, find f composite g as a function of x. F composite gx equals f gx, which gx is the input for function f, and gx equals x squared. Therefore, the input becomes x squared for function f. Now look at function fx. Fx equals 1 plus x. Therefore, the input now is x squared, which we get fx squared is equals
Example 2.
1 plus x squared. If fx equals 2x minus 1 and gx equals x cubed, evaluate g composite f3, f composite g3, f squared 3, and f3 squared. Solution. Fx equals 2x minus 1 and gx equals x cubed. Find g composite f3. 3 is the input for function f. Therefore, substituting 3 into function f, we get 2 times 3 minus 1, which is equals 5. Now, 5 is the input for function g. Gx equals x cubed. Now, the input for g is 5. Therefore, we get 5 to the power of 3, which is 125. For question B, find f composite G3. G3 is the input for function f. Before that, 3 is the input for function g. Therefore, we substitute 3 into the function of gx. It will be 3 to the power of 3. And we get this is equals 27. 27 now is the input for function fx. Fx equals 2x minus 1. F27 equals 2 times 27 minus 1. This is equals 53. Question C. Find f square 3. F square means f composite f. And f square 3 means f composite f3. 3 is the input for function f. If we have fx equals 2x minus 1, therefore f3 equals 2 times 3 minus 1, which is equals 5. 5 now is the input for function f. So we substitute x becomes 5. Therefore, f5 equals 2 times 5 minus 1. And this is equals 9. For question D, find f3 square. f3 means 3 is the input for function f. Therefore, we have f3 equals 2 times 3 minus 1, which is 5. And 5 square equals 25. Take note that G composite F3 is not equals to F composite G3. What can you observe here? Example 3. Find F composite Gx and G composite Fx. For the function Fx equals square root of x and Gx equals x cubed minus 1. F composite Gx means f Gx, which Gx is the input for function f. Gx equals x cubed minus 1. X cubed minus 1 now is the input for function f. Look at here. Fx equals square root of x. Now, the input changed to x cubed minus 1. Therefore, this is equals square root x cubed minus 1. For G composite Fx, it is equals Gfx, which Fx is the input for function g. Fx is equals square root of x. Now, square root of x is the input for function g. If we have gx equals x cubed minus 1, now if we have g square root of x, we change the input as square root of x power of 3 minus 1. For question B, fx equals 4x minus 3, gx equals square root x minus 2. Find f composite gx means f gx. Gx is the input for function f. Now, the input for function f is square root x minus 2. Look at the function fx. Fx equals 4x minus 3. Therefore, if f square root of x minus 2, this is equals 4 square root x minus 2 minus 3, which this is the input for function f now. For G composite fx, this is equals G fx. Fx is the input for function g, which fx equals 4x minus 3. Now, substitute the input for g as 4x minus 3. G input equals square root input minus 2. Therefore, square root input is 4x minus 3 minus 2 equals square root 4x minus 5. Example 4. Find f composite g, g composite f, and f composite g square x. For the function fx equals square root 1 minus x and gx equals 2 plus x. First, find f composite gx. F composite gx is written as fgx. Gx is the input for function f. Substitute gx as 2 plus x. Therefore, we get f2 plus x. Now, 2 plus x is the input for function f. Look at the function f. F input equals square root 1 minus input. Now, we have a new input. Therefore, we have square root 1 minus the new input, which is 2 plus x, which we can simplify to square root negative 1 minus x. Find G composite fx. This is G fx. Fx is the new input. Fx equals square root 1 minus x. Now, use the new input to the function g. Function gx is equals 2 plus x. Now, we change the input to square root 1 minus x. Therefore, we get 2 plus square root 1 minus x. For f composite g square x, this means f composite g composite gx. We need to find gx first, and gx is given as 2 plus x. Now, 2 plus x is the input for function g. Therefore, we have f 2 plus the new input 2 plus x. This is equals f4 plus x. 4 plus x is the new input for function f. Function f is square root 1 minus x. Therefore, we have square root 1 minus the new input, which is 4 plus x, and can be simplified as negative 3 minus x. Example 5. Given fx equals 2 plus x squared, find gx if f composite gx equals 2x squared minus 1. From this example, the composite function is given. Take the left-hand side from the equation. F gx equals f gx, which gx is the input, and this is what we want to find. And we know that f gx is given as 2 plus the new input here, square. Therefore, the new input now is gx, so we have f gx equals 2 plus gx square. And from the question, this is equals to x squared minus 1, which is from the right-hand side. Now, we want to let gx as the subject because this is what the question asks you to find. Therefore, we have gx squared equals to x squared minus 1 minus 2. which is 2x squared minus 3. Now, just let gx as the subject without this square. Square root both sides. We have gx equals plus minus square root 2x squared minus fx equals 2 plus x squared. Find gx if g composite fx is given, equals 1 over x squared. From the left-hand side, g composite fx equals gfx, which fx is already given in the question. Therefore, we have g2 plus x squared from the question. Fx equals 2 plus x squared. Now, this is equals 1 over x squared. What we want is g with a single input, but we have g with 2 plus x squared. Therefore, we need to let this input as a single variable, which is let u equals 2 plus x squared. From here, this equation gives you relations between u and x. Therefore, we can let x as the subject. We have from here u minus 2 equals x squared. Therefore, square root u minus 2 equals x, and this is must have plus minus. Okay, that's why we get x equals plus minus square root of u minus 2. From here, we already let 2 plus x squared as u. Therefore, we get gu equals 1 over x now in terms of u, which is 1 over square root 1 over plus minus square root u minus 2 square, which is this is 1 over u minus 2. Therefore, change the variables in terms of x. So we have gx equals 1 over x minus 2. Example 6. Fx equals square root x minus 1. Find the function g if f composite gx equals 6x plus 11. First, what should we do? Write the composite function. F composite gx equals f gx. Do we have gx? No. This is what we want to find. What else that we have? We have the function fx. Fx equals square root x minus 1. Therefore, f gx equals square root gx minus 1. And from the question, we get f gx equals 6x plus 11. Let gx as the subject. What can we do with the square root? Squaring both sides. By squaring both sides, we get gx minus 1 equals 6x plus 11 squared. And let gx as the subject, we have gx equals 6x plus 11 squared plus 1. Expanding this, we get gx equals 36x squared plus 132x plus 122. Pop quiz. Can you answer this question? If f composite gx equals 4x squared minus 2x plus 1 and gx equals 2x plus 1, find the composite function g composite fx. Hence, find the values of x that satisfies f composite gx equals g composite fx. Solution. Given f composite gx equals 4x squared minus 2x plus 1 and gx equals 2x plus 1. Therefore, f composite gx equals 4x squared minus 2x plus 1 and gx now is 2x plus 1. Therefore, we get f 2x plus 1 equals 4x squared minus 2x plus 1. We want the input for f as a single variable. So we let 2x plus 1 equals u. U equals 2x plus 1. Since function f in terms of x and the new input now in terms of u, we let x as the subject. X equals u minus 1 over 2. Therefore, from here, we get fu equals 4 times u minus 1 over 2 square minus 2 times u minus 1 over 2 plus 1. Simplifying this, we get u square minus 3u plus 3. And this is the function f in terms of u. Now, what should we do is, therefore, substitute all u in terms of fx equals x squared minus 3x plus 1. Since gx equals 2x plus 1, and the question asks you to find g of x, we substitute fx as this function. And it becomes the input for function g. Gx squared minus 3x plus 3 is equals to new input plus 1, which is as 2x squared minus 6x plus 7. Given fgx equals g of x, fgx now is 4x squared minus 2x plus 1, and g of x is 2x squared minus 6x plus 7. We have two quadratic equations, okay? And we need to simplify this equation and find the roots. 2x squared plus 4x minus 6. And we can simplify this equation as x squared plus 2x minus 3. And factorize x squared plus 2x minus 3, we get x plus 3 times x minus 1. Thus, we get x equals negative 3 or x equals 1. Exercise 2. Can you try this exercise? Okay, you should try this exercise and check your final answers as given. That's all for today, and it means end of 4.3.